Hey, welcome back. Up to this point, we have derivative rules that allow us to take the derivative of polynomials, exponentials, logarithms, trig functions, but only if they're being added or subtracted as independent terms. If they're being multiplied or divided, we need new derivative rules, and that's where the product and the quotient rule come into play. Let's start things off with the product rule. If you're taking the derivative of two expressions that are being multiplied together, you're going to take the derivative of the first one times the second one as is, plus the first one as is, times the derivative of the second term. And that is the derivative of that product. If you want to know why this works, there's a link in the description to a why it works video for the product rule. So let's put it to work. Example 1 with the product rule, take the derivative of x squared minus 4x times 2x plus 1. Now, I want to point out, this is a polynomial times a polynomial. We could very easily just multiply these and use the power rule. But for the purpose of practice, I want to use the product rule to take this derivative. So what I've got is x squared minus 4x, we'll call that f, and 2x plus 1, we'll call that g. So the derivative of this product, using the product rule, is the derivative of f prime, 2x minus 4, times g, just as it is, 2x plus 1, plus f, just as it is, x squared minus 4x, times g prime, which is 2. Now, a quick note about simplifying. On the AP exam, once you reduce a problem down to addition, subtraction, and multiplication or division, you can stop. So if this was an AP free response problem, not that it would be, but if it was, you could stop right here, and that would be a safe place to stop. Now, does that mean we don't need to know how to simplify? Of course not. Multiple choice questions almost always have simplified answer choices, so we need to know how to simplify. But it's also important, especially because we're talking about a time test here, to know when you're allowed to stop and move on. So if we go ahead and multiply these together, 4x squared minus 6x minus 4 plus 2x squared minus 8x, combine like terms, 6x squared minus 14x minus 4. If this was a multiple choice question, you can bet this would be the answer that you would have to choose. Example 2, I've got the derivative of the square root of x times x squared minus x. Just like in the first example, instead of distributing, which I could do, I want to practice using the product rule. So first I want to rewrite this because of that square root sign. So this is x to the 1/2 power times x squared minus x. And so the derivative is going to be 1/2 x to the negative 1/2 times x squared minus x plus x to the 1/2 times 2x minus 1. Again, this is a safe place to stop, but we can also distribute, combine like terms, and simplify. Example 3, e to the x times sine x. Look, we can't multiply this out like we could with the polynomials before, so we have to use the product rule. In doing so, it's going to look like this. The derivative of e to the x is e to the x times sine x, just as it is, plus e to the x times the derivative of sine x, that's cosine x, and we're done. It's that simple. Example 4, d dy y to the 5th times ln y. It says d dy instead of d dx. What does that mean? It means take the derivative with respect to y instead of take the derivative with respect to x. It doesn't change how I work the problem. The derivative of y to the 5th is 5y to the 4th times ln y, just as it is, plus y to the 5th times the derivative of ln y, that's 1 over y. And you can leave your answer like this, but I don't think it's too much to ask that we simplify this one more step. 5y to the 4th ln y plus y to the 5th over y, which is y to the 4th. Example 5, d d theta, take the derivative with respect to theta of cosine theta times cotangent theta. So a good opportunity to practice the trig derivatives from topic 8. The derivative of cosine theta is negative sine theta times cotangent theta plus cosine theta times the derivative of cotangent theta, which is negative cosecant squared theta. And use my basic trig rules, I know that sine times cotangent is cosine, and cosine times cosecant squared is cotangent times cosecant. And that brings us to the quotient rule. The quotient rule says if you're taking the derivative of two expressions that are being divided, you're going to take the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom function squared. Now what I want to point out is the similarity between the numerator of the quotient rule, f prime g minus fg prime, and the product rule, f prime g plus fg prime. They're exactly the same, except in the product rule you have a plus in between, in the quotient rule you have a minus, and of course the quotient rule has this g of x squared on the bottom. But if you know the product rule, the quotient rule is not that much harder to memorize. And again, there will be a link in the description to a Why It Works video that shows where the quotient rule formula comes from. So here we go. Example 6. Take the derivative of 3x plus 4 divided by 2x squared plus 1. So using the quotient rule, I'm going to take the derivative of the top, that's 3, times the bottom, 2x squared plus 1, minus the top, 3x plus 4, times the derivative of the bottom, that's going to be 4x, over the bottom squared. Now, a common mistake for students is to take a derivative in this denominator here. You're just going to copy and paste that denominator, but square it. And we can do a little bit of simplifying here, but generally speaking, with the quotient rule, it's hard to really make something simplify very neatly. Example 7, take the derivative of sine theta divided by cosine theta. So here we go. The derivative of the top is cosine theta times the bottom, which is also cosine theta, minus the top, sine theta, times the derivative of the bottom, which is negative sine theta, over cosine squared theta. And while we could stop here, I actually do want to simplify this one out all the way because the numerator becomes cosine squared theta plus sine squared theta divided by cosine squared theta. And if we think back, the one and only trig identity we really need to remember from pre-cal is that sine squared x plus cosine squared x, or in this case, sine squared theta plus cosine squared theta, is 1. So this is equal to 1 over cosine squared theta, which is secant squared theta. And now's a good time to stop and realize this problem, sine divided by cosine, is the same thing as tangent theta. So that's how you show that the derivative of tangent theta is secant squared theta. And I'll have some Why It Works videos that address the derivatives of cosecant, secant, and cotangent, also using the quotient rule. Moving on, example 8, take the derivative of x to the 10th over e to the x. The derivative of the top, 10x to the 9th, times e to the x, minus the top, x to the 10th, times the derivative of e to the x, it's e to the x, over e to the x squared. One thing I notice is that every term here has e to the x in common, so I can rewrite this as 10x to the 9th minus x to the 10th over e to the x. Example 9, take the derivative of x cubed plus 2x divided by the square root of x. Of course, when I see that square root of x, I'm thinking x to the 1/2 power, because that's easier for me to use the power rule on. So the derivative of the top would be 3x squared plus 2 times x to the 1/2 minus x cubed plus 2x times the derivative of x to the 1/2, which would be 1/2 x to the negative 1/2, divided by the square root of x squared. Well, that's just x. And example 10, the derivative of 2 times x squared plus 2x plus 1 divided by 3x. I put this on here because I wanted to show you another way that you can look at this problem. You can look at this as 2/3 times x squared plus 2x plus 1 over x. And when you take a derivative, you've probably noticed this, but we haven't really explicitly stated it. When you take a derivative, a coefficient is just along for the ride. So the derivative of 5 sine theta would be 5 cosine theta. The derivative of 2/3 times x squared plus 2x plus 1 over x is going to be 2/3 times what I get using the quotient rule here. So this derivative is 2/3 times my derivative using the quotient rule, 2x plus 2 times x minus x squared plus 2x minus 1, plus 1 times 1 over x squared. And I want to point out in example 9 and example 10, both of these problems are actually easier if you don't use the quotient rule. In both of these problems, you can split those fractions, simplify those fractions, and use the power rule instead. And so the quotient rule is a good tool, but what you will find is now that you've learned it, you're going to spend the rest of your time trying to not use it, and that's okay. Example 11, f of x and g of x are continuous differentiable functions. Selected values of f and g are given in the table. Given that p of x is f of x times g of x, and q of x is f of x over g of x, find p prime of 1 and q prime of 3. Let's break this into two parts. Let's focus on p of x right now. P of x is f of x times g of x, so the derivative, when we look at this and we immediately notice f of x and g of x are being multiplied together, to take that derivative, I'm going to need the product rule. So the derivative is f prime of x times g of x plus f of x times g prime of x. And so if I'm asked to find p prime of 1, and I'm just going to go ahead and show all my steps here, p prime of 1 is f prime of 1 times g of 1 plus f of 1 times g prime of 1. I'm just plugging 1 in for all my x's. And now all that's left to do is go into my table and substitute these values in. F prime of 1 is 2 times g of 1 is negative 4 plus f of 1 is 5 times g prime of 1 is 6. Negative 8 plus 30 is 22. And for q, we see q of x is f of x divided by g of x. So to take that derivative, I'm going to need the quotient rule. Q prime of x would be f prime of x g of x minus f of x times g prime of x divided by g of x squared. So q prime of 3, I'm going to plug a 3 into all of these. So I need f prime of 3, 10, times g of 3, 5, minus f of 3, negative 7, times g prime of 3, 1, divided by g of 3 squared, 5 squared. So I've got 50 plus 7 over 25 is 57/25. Moving on, we got a handful of AP problems that pertain to the product and quotient rule. The first one's 2008, AB number 89. The table above gives values of differentiable functions f and g and their derivatives at 1. If h of x is 2f of x plus 3 times 1 plus g of x, then h prime of 1 is what? This is kind of the grown-up version of the example that we just did. First, we need to find h prime of x. And in doing so, we notice that I've got two terms being multiplied together, 2f of x plus 3 and 1 plus g of x. So to take that derivative, I'm going to need the product rule. So to start out, the derivative of 2f of x plus 3 would be 2f prime of x. Again, that 2 is a coefficient. It's along for the ride. Times 1 plus g of x plus the first, which is 2f of x plus 3, times the derivative of 1 plus g of x. That would be 0 plus g prime of x. And now that I have h prime of x, all I need to do is plug a 1 into everything. So 2 times f prime of 1 is negative 2, times 1 plus g of 1 is negative 3, plus 2f of 1 would be 2 times 3 plus 3, times g prime of 1, which is 4. Adding it all up here, don't forget your order of operations, is 44. So my answer is D. 2008, BC number 1, f of x equals 3x minus 2 over 2x plus 3. Take its derivative. Okay, I immediately see I'm going to need to use the quotient rule here. So I've got 3 times 2x plus 3 minus 3x minus 2 times 2 over 2x plus 3 squared. So this brings us back to what we talked about earlier. If this was a free response problem, I could stop here, but this is a multiple choice problem. Do any of my answer choices match this? No, so I'm going to need to combine like terms here. What I do notice is that all the denominators are 2x plus 3 squared, so I really only need to simplify the numerator. So distributing, I get 6x plus 9 minus 6x plus 4. 6x minus 6x cancels out. 9 plus 4 is 13. So my answer is 13 over 2x plus 3 squared, and my answer is D. 2012 AB number 1, y equals x sine x. Take the derivative. I see x and sine x are being multiplied together, so I'm going to use the product rule. The derivative of x is 1, so I get 1 sine x plus x times cosine x, and it really is that simple. My answer is B. Last one, 2012 ABBC number 19. The function f is defined by f of x equals x over x plus 2. What points x comma y on the graph of f have the property that the line tangent to f at the point x comma y has a slope of 1/2? So it may not be immediately clear what you're being asked for. You need to really pick out these important key phrases. I see the line tangent to f has a slope of 1/2. So if we're talking about the slope of the tangent line, that's the derivative. The slope of the tangent line is the derivative. So this is saying, where is the derivative equal to 1/2? So I'm going to take my function, x over x plus 2, take the derivative using the quotient rule, 1 times x plus 2 minus x times 1 over x plus 2 squared. And I'm going to set this equal to 1/2 and solve. So just combining like terms here in my numerator, I have x plus 2 minus x. So I've got 2 over x plus 2 squared equals 1/2. I can cross multiply. X plus 2 squared equals 4. I can square root both sides, but be careful. When you square root both sides, what's the square root of 4? It could be 2, and it could be negative 2. So now I have two equations to solve. X plus 2 equals 2, so x could be 0. X plus 2 equals negative 2, so x could be negative 4. And looking at my answer choices here, I only have one answer choice that has 0 and negative 4, so my answer is C. What if two answer choices had 2 points that started with 0 and negative 4? I would have to take these x values and plug them back into the original equation to get the y values. Now, I didn't have to in this case, but you might, so that's something to keep in mind. So to recap, now we can take the derivative of expressions that are being multiplied together or divided using the product rule and the quotient rule. The product rule is f prime g plus fg prime. The quotient rule is f prime g minus fg prime over g squared. Again, if you want to know where these formulas come from, check out the links in the description. Hope that helps. Thanks for watching.